evaluation of definite integrals by substitution. What did we learn? One very basic difference between substitution method in indefinite integrals and definite integrals is that when the variable was changed in the indefinite integration, in that case, the substitution in terms of new variable affected two places, the integrand and the differential, from dx to dt if t is the new variable introduced. Whereas when the variable is changed in the definite integral, the substitution is affected at three places: the integrand, the differential and the limits. If the original variable of integration was x, that means the limits were values of x. If the new variable is t, the differential changes from dx to dt and the limits are now in terms of t, that if x is varying from here to here, then according to the substitution, t is going to vary from where to where. So if the original definite integral was from a to b, a the lower limit, b the upper limit, after substitution it will not be a and b, it will be c and d. If the original a and b were values of x, which was the original variable of integration, now c and d will be the values of the new variable t. And therefore, the only thing to be kept in mind if you are substituting inside the integral is that when the variable is changed, in definite integral, then the substitution is affected at three places. Unlike 2, which was the case in the indefinite integral, here three places get affected in the case of definite integral, which are first and foremost the integrand. If your new variable is t, wherever there is x in the integrand, it will be converted in terms of t, however you have substituted. Next, the differential. If originally the differential was dx, now it will become dt if t is your new variable brought into picture. And the third, because it's definite integral, and what makes an integral definite is the incorporation of the upper and lower limit. So therefore, limits happen to be the third thing which gets affected due to substitution in a definite integral. Okay, this is a very, very important point to be kept in mind while you are adopting the substitution technique to simplify your definite integral to get its value. Okay, moving on to an example upon it. If I ask you to compute the definite integral of sin x plus cos x upon 9 plus 16 sin 2x dx from 0 to pi by 4, how are you going to do this? Over here, see, if you just consider the integrand, it is playing the role of fx, right? This is my lower limit, which I denote by small a, and this is my upper limit, which I denote by small b. By FTC, or the fundamental theorem of calculus, we know that definite integral of fx from a to b is phi of x from this a to b. That is equal to, this is just a notation to write phi of b minus phi of a, where what is phi of x? So until and unless you get phi of x, you cannot compute phi of b and phi of a. So where phi of x is one integral of f of x, one primitive of f of x, one antiderivative of f of x. So in order to compute the definite integral, I will have to compute first the indefinite integral of f of x, just one in terms of x. So let's do that, because this is what is the ultimate aim. If you consider integral of f of x, which is sin x plus cos x whole upon 9 plus 16 sin 2x, its indefinite integral. As you can see, sin x plus cos x sitting in the numerator, you are going to take what as t? Sin x minus cos x is obvious to be taken as t, because sin x plus cos x is sitting in the numerator. Why? Let's see. If you take sin x minus cos x as t, this is where you are making a substitution, right? If you take sin x minus cos x as t, sin x minus cos x as t is going to give you what? This will be now sin x minus cos x t. Next thing will be differential from dx will be converted in terms of dt. So differentiate both sides with respect to t. Because here it's a function of x, I will be differentiating this with respect to x multiplied by dx by dt by chain rule. So differentiate sin x with respect to x, you get cos x minus. Differentiate cos x with respect to x, you get minus sin x into dx by dt equals 1. Or I can say cos x plus sin x dx is dt. And therefore, this converts your indefinite integral to what? Therefore, indefinite integral of sin x plus cos x whole upon 9 plus 16 sin 2x dx will be equal to what? So over here, sin x plus cos x dx is dt. So entire numerator is converted to dt. In the denominator, you have 9 plus 16 sin 2x. Now obviously sin 2x has to be written in terms of t, right? Because that is how my substitution affects the integrand. My differential has been changed from dx to dt. The integrand also has to be written completely in terms of t. No original variable of integration should be seen in the integrand if the substitution has been implemented. So over here, how am I going to write sin 2x in terms of t? I have sin x minus cos x is t. Let's try to see how will that story be used. If sin x minus cos x is t, sin x minus cos x whole square is t square. Sin x minus cos x whole square is sin square x plus cos square x minus 2 sin x cos x equals t square. Sin square x plus cos square x is 1. You get 1 minus 2 sin x cos x is sin 2x equals t square. And therefore, sin 2x comes out to be equal to 1 minus t square. And that is how you have successfully been able to write sin 2x also in terms of t. So over here I will be writing 9 plus 16 sin 2x, which is 1 minus t square. Understood? So this is equal to what? Integral of dt upon 9 plus 16 minus 16t square, which is integral of dt upon 9 plus 16 is 25 minus 16t square, which eventually gives you dt upon, if you take out 16 common, if you take out 16 common from the denominator, you will be left with 25 by 16 minus t square, or it will be equal to dt upon 5 by 4 whole square minus t square, right? This I am talking about indefinite integral. Here if I try to compute this integration, what will that become? You know this is 1 by 16. Integration of 1 upon a square minus x square. That is what it is going to be. This is 9 plus 16 into 1 minus t square, which gives you what? 9 plus 16 minus 16t square. You get 25 minus 16t square, which eventually gives you 25 by 16 minus t square, which is 5 by 4 whole square minus t square. So 1 upon a square minus x square is 1 upon 2 into a, 2 into a, log of mod of a minus x, a plus x upon a minus x, a plus x upon a minus x, 5 by 4 plus t upon 5 by 4 minus t, right? Once you have obtained your solution till here, what is the next step? What is this? This is basically, if I further simplify, you get what? 5 by 2 is written over here, you get 1 by 40 ln of mod of 5 by 4 plus t upon 5 by 4 minus t. Now, carefully observe, if your integrand whose integral you wanted to find from 0 to pi by 4 has been changed to this integral after the substitution, therefore that means now you need to find this particular integral's definite integral from 0 to pi by 4. So now is the third effect going to come into picture. How? This was from 0 to pi by 4. When the substitution was made, everything was x, everything whichever was x was written in terms of t, differential was changed from dx to dt. What about the limits, right? What about the limits? So limits were from 0 to pi by 4. When x is 0, what happens to t? When x is pi by 4, what happens to t is what is important at this particular point of time. And so, what is it that we are going to have? Over here, if I have x equals 0, that's the lower limit, 0 to pi by 4. If x is 0, what is t? T is sine 0 minus cos 0. Sine 0 is 0. Cos 0 is 1, 0 minus 1 gives you minus 1 as the value of t corresponding to x equals 0. So when x is 0, t is minus 1. And when x is the upper limit pi by 4, when x is pi by 4, t is sine pi by 4 minus cos pi by 4. Sine pi by 4 is 1 by root 2, cos pi by 4 is 1 by root 2. 1 by root 2 minus 1 by root 2 gives you 0 as the value of t corresponding to the upper limit of x, that is pi by 4. So if x is ranging from 0 to pi by 4, after substitution when everything gets converted in terms of t, t is going to vary from 0 to minus 1. Understood? If t is going to vary from 0 to minus 1, my aim was to compute this integral. And so, now I am in a position to do that. How? See. Therefore, integral from 0 to pi by 4 sin x plus cos x whole upon 9 plus 16 sin 2x dx, and these are the limits of x, right? What is this equal to? This will be equal to, we have just made all the substitutions, it came out to be equal to this integral of dt upon 5 by 4 whole square. This was 1 by 16 integral of dt upon 5 by 4 whole square minus t square. What about the limits? When the integrand is changed in terms of t completely, this is the simplified integrand, this is my differential in terms of t. If x is varying from 0 to pi by 4, t is varying from minus 1 to 0. When x was 0, t was minus 1. So, if the lower limit in terms of x is 0, lower limit in terms of t will be minus 1. When x was pi by 4, t was 0. So, when the upper limit in terms of x is pi by 4, upper limit in terms of t will be 0. These are my values of t. That means now definite integral of this integrand will be what? This integrand, its definite integral from minus 1 to 0 will be what? Well, compute its antiderivative, that means compute its indefinite integral. Its indefinite integral we had computed, it came out to be 1 by 40 ln of 5 by 4 plus t upon 5 by 4 minus t, right? That is its indefinite integral. It was 1 by 40 ln of mod of 5 by 4 plus t upon 5 by 4 minus t. Its indefinite integral evaluated at t equals minus 1 and t equals 0. The exact same thing which I had to do with this particular integral, I did it with its substitute integral. So, this was modified to this and the exact same definition of FTC was applied over here, and this is what I got. This is the indefinite integral of this particular function. Its values I am evaluating at minus 1 and 0. What are they? If 1 by 40 I keep outside, what is it that I am left with? Ln of mod of 5 by 4 plus 0 upon 5 by 4 minus 0, which is 5 by 4 upon 5 by 4, minus ln of 5 by 4 minus 1, which is 5 minus 4 by 4, which is 1 by 4, upon 5 by 4 minus of minus 1, which is 5 by 4 plus 1, which is 5 plus 4 by 4, that is 9 by 4. Right? So, this becomes eventually equal to what? Let us see. This eventually becomes equal to what? This will be 1 by 40 ln of 1 minus ln of 1 by 9, which gives you 1 by 40, 0, ln 1 is 0, minus ln of a by b is ln 1 minus ln 9. ln 1 is again 0, you get 1 by 40, 0 minus 0 plus ln 9, which gives you ln 9 by 40 as your answer. Or ln 3 square by 40, it can also be written as 3 square will become twice of ln 3 by 40, which gives you ln 3 by 20. That's how you obtain your answer by substitution method. Your complete integrand, or I should say the complete integral, has become now a new integral. In this new integral, the substituted integral, wherein the integrand is written in terms of t, differential is written in terms of t, limits are written in terms of t, now apply your FTC. Now apply your FTC and get your answer. That is what is your final answer. First question says integration of fx, which is given to be as under root 1 plus x square with respect to not x, but this time x square will be what? So question is basically asking you to integrate under root 1 plus x square, but with respect to x square itself. Now if you can understand, because 1 is a constant, therefore this can be written as or rewritten as d of 1 plus x square. Right? D of x square is same as d of 1 plus x square, 1 is mere constant. Now what I do is, if I take 1 plus x square as t, if I take 1 plus x square as t, I get integral root t dt, which is something very, very easy, you know. This is nothing but equal to 2 by 3 t to the power 3 by 2. But that's not the answer, because t is being taken as 1 plus x square. So your answer is 2 by 3 1 plus x square to the power 3 by 2, and that is what is the indefinite integral of under root 1 plus x square with respect to x square. So 2 by 3 1 plus x square to the power 3 by 2 plus obviously the constant of integration, and therefore B is the correct answer. The next question says what? It says that if integral e to the power ax cos bx dx is given to be this, then f double dash x will be equal to what? So you are given the information of a certain expression. On the basis of that, you are being asked to compute f double dash x. Now if you can recall from this expression, this is something we have already witnessed, and we know the general scenario which follows for this particular expression. Why? We know that integral e to the power ax cos bx dx is actually equal to, it is given in the question as something else, but it is actually equal to e to the power ax upon a square plus b square, a cos bx plus b sin bx, right? But this has been given equal to e to the power 2x by 29 fx plus constant of integration. Obviously plus c is going to come in both the places. So if you compare both these expressions, what you get is a is 2, clearly a is 2. Also you get that a square plus b square is 29. If a square plus b square is 29, I get 2 square plus b square is 29. So b square is 29 minus 4, that is 25, so b is 5. A is 2, b is 5. Also if you compare, you get fx is a cos bx plus b sin bx. Now if fx is a cos bx plus b sin bx, then what is f dash x? It is minus a b sin bx. Why? Because a constant, d by dx of cos bx is minus sin bx into b. So minus sin bx into b, plus here it will be b square cos bx, right? Again if you differentiate, You get what? Minus AB is already here, square cos bx. And here it will be minus, this is what? B, this was cos bx, so b square, and then here you get b cube sin bx. Isn't it? Because d by dx of cos bx is minus sin bx into b, b square is already over here. So from here if you take out minus b square common, you are left with a cos bx plus b sin bx. Isn't it? Isn't it? This is minus a b square cos bx minus b cube sin bx, but a cos bx plus b sin bx is equal to fx. So f double dash x has come out to be equal to minus b square fx. But we know that b is equal to 5, so your answer is minus 5 square fx, that is minus 25 fx, and that is what is f double dash x. It has come out to be equal to minus 25 fx or minus b square fx, where b is 5. Clear? Easy enough question. Next we have, if integral fx dx is this, then fx will be what? Okay, so let's see how to tackle this question. Okay. So integral fx dx is given to us as what? Integral fx dx is given to us as twice of fx whole cube plus c. If you differentiate both sides with respect to x, because I want fx, so I don't want this integral sign, I want my fx to get rid of this integral sign. D by dx, when you do, you are just left with fx. This is 2 constant, 3 into fx whole square into f dash x. So over here you get 6 fx whole square into f dash x. Right? This is what you get by chain rule. After this, you can see fx over here, 1 fx gets cancelled, you are left with 6 fx f dash x equals 1. From here, the very situation of obtaining fx starts. You can write this as this is d by dx of fx equals 1, which alternatively can be written as what? 6 fx d of fx equals dx, and now you can integrate both sides. Here with respect to fx and here with respect to x. When you do this, what is it that you get? You get 6. Integration of x dx is x square by 2. So here you get fx square by 2. And this is equal to x. You are left with fx whole square is x by 3. So fx you are having as under root x by 3. That is how you compute your fx when you have the information that integral fx dx is twice of fx whole cube. Now if I move towards the next question, let's see what that calls for. Question is, if this is equal to a log x plus 1 plus b log x minus 2, then what is the relationship between a and b? Now you can see over here, integration by partial fractions is going to come into picture. It is very, very simple. Integral of 1 upon x plus 1 into x minus 2. This will be what? If you put x equals minus 1, I have taught you already in my lectures how to get the values. If you put x equals minus 1, you get 1 upon minus 3. Just ignore this expression, put x equals minus 1. You get 1 upon minus 3 or minus 1 upon 3 times 1 upon x plus 1. That's what you get. Plus, if you put x equals 2, not in this expression, in the rest of the expression, x equals 2 gives you 1 upon 3. So you get 1 upon 3 times 1 upon x minus 2, and you need to integrate this now. Now it's very, very easy. This gives you minus 1 by 3 log of x plus 1 plus 1 by 3 log of x minus 2. And this is exactly equal to the expression a log x plus 1 plus b log x minus 2. and therefore you get that a is minus 1 by 3, b is 1 by 3, so a plus b clearly is coming out to be 1 by 3 plus minus 1 by 3, which is 0. Easy enough question, just using the very partial fraction scenario of integration. If integral fx dx is fx, then what is integral fx square dx? Let's see how to tackle this question. Integral fx dx is fx. If integral fx dx is fx, it clearly means d by dx of fx is fx. d by dx of fx is fx means I can write this as 1 by fx d of fx equals dx, right? And now I can integrate both sides. This gives me log of fx equals x plus some constant of integration. Log already I have. I'm going to just take for convenience log c as the constant of integration. Now I can write this as fx equals e to the power x plus log c, which is e to the power x into e to the power log c, which is e to the power x into c. Fx is c into e to the power x, so fx whole square will be c square e to the power x whole square, which is this. And when you integrate fx whole square, you actually integrate this, which comes out to be what? C square is constant, integration of e to the power 2x is this upon 2, right? And your answer comes out to be 1 by 2 c square into e to the power 2x, which actually is this. Fx whole square is this, fx whole square c square into e to the power 2x into 1 by 2 is what is the integration, right? So integration of fx whole square dx is what? 1 by 2 fx whole square, right? Just this 1 by 2 is going to come out, rest fx whole square remains the same. Clear? Moving to the next question, we have what is the absolute value of this given integral expression? Okay. So talking about this, you need to first focus upon the values which x can basically acquire in this expression. For this question, I am given that x is going to range from 10 to 19. So x is already given to be greater than equal to 10 and less than equal to 19. Greater than equal to 10 means what? X to the power 8 will be greater than equal to 10 to the power 8. Obviously, if I add 1 to it, again the inequality holds. So this is something that you already have. Now over here you need to find the absolute value of this expression, means you need to find this. What is this? You know that mod of the integral is less than equal to integral of the mod of cos x upon mod of 1 plus x to the power 8. But 1 plus x to the power 8 is already positive, so there is no need to put this mod sign. So this dx. Now if 1 plus x to the power 8 is greater than equal to 10 to the power 8, this implies 1 upon 1 plus x to the power 8 is less than equal to 1 upon 10 to the power 8, which is 10 to the power minus 8. So over here you know that mod of cos x is always less than equal to 1, right? For any x which is coming from any real number, mod of cos x is always less than equal to 1. So this is less than equal to 1, and 1 upon 1 plus x to the power 8 is less than equal to 10 to the power minus 8. So 1 into 10 to the power minus 8, which is this. So obviously this comes out to be equal to what? This comes out to be equal to what? 10 to the power minus 8 into x, where x is ranging from 10 to 19. So that is going to give you 19 minus 10. This is 9 into 10 to the power minus 8, which is clearly less than 10 to the power minus 7. If it is clearly less than 10 to the power minus 7, option number A is the correct one. The only thing to be used over here is the very simple concept that mod of the integral is less than equal to integral of the mod, and that mod of cos x is always less than equal to 1 no matter what real number x is acquiring. Next question says, if fx is a periodic function with period t, then which among the following is the correct statement? Now over here, if you remember the theory part that we've done, directly you will be able to see the answer. Which one is it? It is option number C, isn't it? Why? Because we know that integral a plus nt to b plus nt fx dx is equal to integral a to b fx dx, and this is true for all integers. Over here specifically for n equals 1 the expression is given to you, a plus 1t b plus 1t. See, a plus 1t b plus 1t fx dx is a to b fx dx. So this is obviously right. If you have just the knowledge of basic, very basic properties which functions which are periodic with period t acquire, very directly you will be able to get the answer. Fine. The next question says what? Let fx be equal to this, then the roots of this equation are what? Real roots. Okay. Let's see. So fx is this, that means what is f dash x? If fx is this, what is f dash x? It is under root 2 minus x square and not t square. If f dash x we know, I am interested in this equation, x square minus f dash x equals 0. X square minus, this is f dash x, equals 0. X square equals 2 minus x square with under root. Squaring both sides, I get x to the power 4 equals 2 minus x square, which is x to the power 4 plus x square minus 2 equals 0. You can write this as t square plus t minus 2 equals 0, where t is x square. Now this is a quadratic equation. T will be equal to minus b plus minus root over b square minus 4ac upon 2a. So this gives you minus 1 plus minus 3 by 2, which eventually gives you 1 and minus 2 as the answer. First one is to evaluate this particular integral. Now if you carefully observe, very clearly x plus 3 to the power 5 needs to be expanded, and in the numerator you can see there is x common in every term. So let's simplify this. You basically are going to get x is going to come out common from the numerator. You have x cube plus 4x square plus 12x plus 9. And now expand x plus 3 whole to the power 5. Binomial expansion, you know, this comes out to be x to the power 5 plus 15x to the power 4 plus 90x cube plus 270x square plus 405x, and then you have plus 243. Apart from this expansion, you have minus x to the power 5 minus 243. Minus x to the power 5 minus 243 dx. So clearly this gets cancelled out and this gets cancelled out. Now in every term you see in the denominator there is x common. So again x is going to come out common and is going to get cancelled out with this x. I am going to be left with x cube plus 4x square plus 12x plus 9 whole upon x came out common, got cancelled with this x. I am left with 15x cube plus 90x square plus 270x plus 405. Okay. Now if you can see, if I put minus 1 over here, in place of x if I put minus 1, I basically get the numerator turning out to be 0. If at minus 1 numerator is 0, that means x plus 1 is a factor of the numerator. So numerator can be written as x plus 1 into something. What is that something? Let's find out. We have x cube plus 4x square plus 12x plus 9, and I know x plus 1 is a factor because minus 1 is a 0. So x into x square gives you x cube plus x square, which gives you 3x square plus 12x plus 9. Then you have x into 3x, so this gives you 3x square. Then you have plus 3x minus minus. Then you have 9x plus 9, so you have plus 9. Then you have 9x plus 9 minus minus and 0. So you are getting x square plus 3x plus 9. Exactly in a similar fashion, if I talk about the denominator, 15 can come out common, and then you will be left with x plus 3 into x square plus 3x plus 9. This expression is common, got cancelled. Now what you have? Let's see. Now your I is 1 by 15, integral of x plus 1 upon x plus 3. X plus 1 upon x plus 3, you need a 2 to get x plus 3, and you subtract 2 as well, upon x plus 3 upon x plus 3 dx. X plus 3 upon x plus 3, you are now left with 1 minus 2 upon x plus 3 dx, which is 1 by 15. This turns out to be x minus twice of ln of x plus 3 plus c. So what is your answer? 1 by 15, x minus twice of ln x plus 3 plus c. What is it? This. Fine. 1 minus 15, x minus twice of ln x plus 3 plus the constant of integration. Let's look at the next question we have. If I is given to be this integral and the answer is given in the form of an unknown function with some unknown a, b's and k. So over here, the question is to determine a, b, the question is to determine fx, all these things. In here, if I talk about this integral, I am interested in taking the numerator to be equal to t. So if I take t equals under root 1 plus ln x, t square is 1 plus ln x. So 2t dt equals 1 by x dx. So what does my integral become? I turns out to be under root 1 plus ln x was just a t, x dx. So here obviously there is dx. Dx upon x is 2t dt, and ln x is t square minus 1. So I turns out to be 2t square upon t square minus 1 dt. From here I can say I is t square minus 1 plus 1 upon t square minus 1, and here also. Obviously this gets cancelled out. You are left with 1 plus 1 upon t square minus 1 dt. Now what you have next is, after this step, you have direct formula with you. Integration of 1 dt is t plus 1 by 2 ln of mod of t minus 1 upon t plus 1 plus c. Not a problem. So this eventually becomes, or let me keep it as a k because that is what is given in the question. So now I have 2t plus ln of mod of t minus 1 upon t plus 1 plus k. T is what? T is under root 1 plus ln x plus ln of mod of under root 1 plus ln x minus 1 upon under root 1 plus ln x plus 1. If you compare it to the right hand side given in the question, it is a times fx. If I say this is my fx, then a is 2, b by 2 times ln of. So b by 2 times, I can write this as 2 by 2 times. So b turns out to be 2. ln of fx plus c upon fx plus d. This is fx plus c. C is minus 1 upon fx plus d. D is 1. So now you have to understand, is c plus d 0? Well, if you talk about c and d, c is minus 1, d is 1. Yes, of course, c plus d is 0. So option number A is correct. Is A equal to B? Let's see. A is 2, B is 2. So yes, A is equal to B. Fine. Is fx equals under root ln x? No, it is equal to under root 1 plus ln x. But this is saying is fx equals to ln ex? Yes, of course. Why? Because fx is under root 1 plus ln x. 1 can be written as ln e to the base e plus ln x to the base e. which becomes ln xe on ex. And therefore, yes, this is also true. Okay? Moving to the next one, we have I is given to you, and again this is equal to a certain function a fx whole to the power b plus c. In that situation, question is talking about evaluating a, b, c, fx, all these things. Here if you can see, here it is 3, here it is 5. Just if I have 2 more of x plus 7s, I am going to get x plus 7 and x plus 5 both having the same power 5. So let's do that. This will be x plus 7 whole to the power 5 upon x plus 5 whole to the power 5. I have multiplied by x plus 7 whole square. So I will be dividing also by x plus 7 whole square. Clear? Now you have what? This becomes x plus 7 upon x plus 5 whole to the power 5 into 1 upon x plus 7 whole square. Now I do something very smart. What I do is I write this as x plus 5 upon x plus 7 whole to the power minus 5 into 1 upon x plus 7 whole square dx. Now why do I do this? Because my next target is to take t equals x plus 5 upon x plus 7. When you do this, you eventually end up getting x plus 5 plus 2 minus 2 upon x plus 7 upon x plus 7. From here x plus 7 gets cancelled. You have 1 minus 2 upon x plus 7. Now when you differentiate, you get dt by dx equals 1, or I should say 2 upon x plus 7 whole square. That means dx upon x plus 7 whole square is dt upon 2. Dx upon x plus 7 whole square is dt upon 2. So you basically get t to the power minus 5 dt upon 2. That is why I had reciprocated this, so that this term can be dealt with when I am substituting. Now that we are done till here, what is the next step? Here you have, this is pretty simple, t to the power minus 5 plus 1 upon minus 5 plus 1, right? Obviously plus c. So you have minus 1 by 8 t to the power minus 4. What is t? T is this, whole to the power minus 4, or its reciprocal to the power 4, which is x plus 7 upon x plus 5 whole to the power 4 plus c. And therefore you have, answer is a times fx whole to the power b. So this is a, this is fx, and this is b. Okay, what is a? A is minus 1 by 8, b is 4, and fx is x plus 7 upon x plus 5. This is fx. Is twice of ab equals minus 1? Let's see. Twice of a into b. Twice of a into b. Yes, it is equal to minus 1. So twice of ab, yes, it is minus 1. In fact, 32 times a plus b is also 0. You can see 32 times minus 1 by 8 gives you minus 4. Minus 4 plus b, that is minus 4 plus 4 eventually gives you 0. Because fx is this, fx is not this, and hence you have 3 options correct out of 4. Moving to the next question we have. The question is basically talking about matching the entries in the first column to the entries in the second column. Let's see what they're trying to say and ask. It is just talking about simply antiderivatives. What is it saying? It's saying, let's look at the first one. Sec x upon sec x plus tan x whole square. Sec x upon sec x plus tan x whole square dx. Again, if you have this long-sightedness, you can see the moment I am interested in taking sec x plus tan x equals t, there is a certain kind of problem which is going to occur when I substitute back the terms in here in the integral. So what I do is, I multiply the numerator and denominator by sec x plus tan x. So from here I get sec x plus tan x whole cube, and this is dx. Okay. Now I take sec x plus tan x equals t. So d by dx of sec x is sec x into tan x. D by dx of tan x is sec square x, and this is dt by dx. So from here sec x comes out common. I am left with sec x plus tan x equals dt by dx. So you basically get dx into sec x plus tan x is dt. Dx into sec x plus tan x is dt. So you get dt upon t cube. This comes out to be t to the power minus 3 dt, which is minus 3 plus 1 upon minus 3 plus 1. This is t to the power minus 2. T to the power minus 2 upon minus 2. T is what? Or I can say this is 1 upon t square. Then what is t? T we have taken as sec x plus tan x. So this becomes 1 by 2 sec x plus tan x to the power minus 2 plus c. Let's see what we have. We have minus 1 by 2 sec x plus tan x to the power minus 2 plus c. So A gets matched to Q, or I can say this is what I will be shading. Talking about the second one, I have cos x upon sin x minus 1 into sin x minus 2. Let's talk about this integral now. So we have to find the antiderivative of this particular function. It is cos x upon sin x minus 1 into sin x minus 2 dx. Okay. Here what I do is I take sin x equals t. When I do this, I get cos x equals dt by dx, or cos x dx is dt, cos x dx is dt upon sin x is t. So you get t minus 1, t minus 2. Pretty simple. Open by partial fractions. You get 1 upon t minus 2 minus 1 upon t minus 1 dt, which eventually gives you ln of mod of t minus 2 minus ln of mod of t minus 1, which is ln of mod of t minus 2 upon t minus 1 plus c. T is what? Sin x. So you get ln of mod of sin x minus 2 upon sin x minus 1 plus c. So B basically gets matched to P. Clear? Talking about the third one, it is sin inverse of 2x upon 1 plus x squared. Now see, in expressions like this, something which is very much based upon the common sense is used. Here if I am interested in sin inverse of 2x upon 1 plus x square dx, it's very evident for me to take x equals tan t, because I know 2 tan t upon 1 plus tan square t is sin t. So I will be left with sin inverse of sin t, which is t. That's what I have. Why? Because this becomes 2 tan t upon 1 plus tan square t becomes sin t. Sin inverse of sin t gives me t. What about dt? This is dx equals sec square t dt. So write it down, sec square t dt. When you open this up by parts, this is the first function, this is the second function. You take algebraic, I let you follow, a comes before t. So here I say first function into integration of second minus integration of differentiation of first function into integration of second dt. So you get t tan t minus log of mod of sec t plus c. In place of t, when you are going to substitute tan inverse x, in place of tan t, when you are going to substitute x, you basically are going to get 2x tan inverse x minus log of 1 plus x square plus c. So this gets matched to r.